Torej, dr. Dillo je namestnica DANS-a, to je Data Archiving and Networking Services. Danes bo tudi največ o tem govorila, drugače je pa doktorila iz zgodovine in je najbolj dejavna na razvoju politik za različne ključne deležnike. Tako je sodelovala z Ministrstvom za izobraževanje, kulturo in znanost, za Nizozemsko nacionalno knjižnico. Zanimajo pa tudi upravljanje z raziskovalnimi podatki in certificiranje digitalnih repozitorijev. Je tudi podpredsednica odbora za RDA, Research Data Alliance, članica različnih združenj, koordinira pa tudi Horizont projekt FAIRsFAIR. So I will switch back to English, just do a quick introduction to FAIR and open research data from the ELIXIR perspective. ELIXIR is a distributed research infrastructure for life science information and life science data. It's very likely, I think, the largest AS-free research infrastructure in Europe. It has 22 members from 21 countries, plus EMBL and one observer country, 23 nodes, and one hub, which is located in Kingston, UK. It's a virtual distributed infrastructure. It contains it is consisted from 5 platforms and many use cases, now called communities. Very important for FAIR and open data is here. You see, we want to actually provide access to free, open resources, regardless of location. There are already more than 140 resources within ELIXIR that are openly available with the open data. From the strategic objectives, we just published a new ELIXIR 5 years program, and from the strategic objectives, we also count on very strong collaboration with EOSC, and on open and federated service network of different data resources and data services. Of course, the data services should be fair. A few quotes from the ELIXIR program. First one, ELIXIR has actively contributed to the development of open data policies and FAIR concept. Especially important is FAIR data management in life sciences. So we will also provide different services for the life science data management and training in that area. Very important is also that ELIXIR is leading the joint biomedical sciences research infrastructure consortium in EOSC. It's called EOSC Life. So FAIR and open data in Slovenia. You already heard that we have, since 2015, national strategy of open access for the scientific publication and research data, which is now, being implemented. We have a Slovenian National Research Infrastructure Roadmap, where is also ELIXIR Slovenia as one of the landmarks. We just submitted the application for a national call for research infrastructure funding, and if that will be successful, we hope that it will be, we will be able to build archive of life science data, which will also be part of federated EGA. This is European Genotype and Phenotype Archive. Of course, we also plan collaboration with other ESFRIs, collaboration with EOSC and e-infrastructures. You probably know the HPC River project already in implementation phase. We are collaborating with RDA Node Slovenia in 1 million genomes declaration and other associations and declarations like Global Alliance for Global Health. To conclude, open biological data drives research, and for that we need sustainable databases that are interoperable, that are fair, that are safe and secure. From that, at this point I will conclude, and I invite Dr. Dillo to give her presentation. Yeah. Thank you.
So good morning, everyone. I'm really delighted and honored to be here today and to have been invited to speak to you today. And we are going to shift gears a little bit, but I think that the first two presentations that we had form an excellent, let's say, context from which I can start. We heard a lot about open access. We zoomed in on open access in the area of publications. And now I want to go to yet another aspect of open science, of which we already heard from René, which is the sharing of data. And I want to talk about whether sharing research data is a fairy tale or not. We already heard that there is this discrepancy between the personal benefit of a researcher in maybe not sharing data and the good for all. So, but before I start my presentation, I want to do a little experiment with all of you in the room to keep you awake, because we are nearing lunchtime already. So if you could pull up a mobile phone for me, that would be really great. And I'm going to try to shift. Let's see. Because I want to do a little poll to see who you are. Oh, it's the other mouse click probably. Yeah. So if you could go to menti.com on your mobile, www.menti.com, and then type in 909220 as a code. Everyone who has a mobile phone, and I'm pretty sure that you all have one, and you can also do it on your laptop. It's on the screen. I'll make it. It's menti.com, and I'll go to the code is 9092. Oh, it's the other button. Sorry. This is a bit bigger. 909220. And my first question to you is, who are you? So, to which of the groups that I have on my screen do you belong, so that I get a sense of whom I'm talking to this morning? Ah, and you have found it. You have found it. Yes, yes. The results are coming in. And we have a diverse audience. So people from all the categories that I could think of in this room. Very good. So we have students, a lot of researchers, a lot of librarians as well. Yeah. Very good. They should be very aware of the importance of research data. So that's nice to see. 35 people have answered the questions, and I see a lot more people in the room. So maybe with the next question, we get more people involved. So let's move. Still answers coming in. So the librarians are winning this competition. Interesting. Good.
It's not the right metrics.
No, don't go there. Don't go there. This is just for fun, you know. So now I need to see. Now we go to the next one. Again, the wrong one. So how familiar are you with the concept of FAIR? So that I get an idea. So there as well, a mixed concept, although there are not many people in the room who haven't heard from the acronym at all. And the majority has heard of the concept. Very good. Great. So have you produced research data yourself? Is there anyone in the room who produces research data in their daily jobs? That's what you get when you have a lot of librarians in the room, right? Okay. A small minority has produced research data very often, but a lot of people have some experience with it, so that's good. Oops. So the next one then is, have you ever reused data produced by other researchers? And again, a majority has. So there is sharing of research data going on here. Have you ever written a data management plan in one of the projects that you have been involved in? We depend on the researchers in the room here for these questions, and not the librarians probably. Yeah. Good. So, and I think I now move to the final one. Which 3 words come to your mind when you think of the concept of FAIR data? So you can fill out 3 answers, and they will become visible on the screen, but you can do that anonymously, so you can write anything you want that comes up in your head. Don't be shy. Ah, there's the first one. So I see the 4 letters returning here. Free in the middle, access, of course, yeah. So this will be an interesting word cloud to have a look at after my talk maybe and see whether there is some correlation between the 2. Great, so I see a lot of concepts that will come somewhere in my talk. So thank you very much for that. Everyone is awake, so I can start. And I go back to the presentation. There we go. So sharing research data, is it a fairy tale? This we already did. What I want to do is say 3 words about dance, then zoom in on the importance of data sharing in general, but I think a lot of it has been said already in a wider context here this morning. Then I want to zoom in on the FAIR principles. What are they? How do they, for example, relate to other terms like open data? And finally, I want to present to you an example of an implementation of FAIR in, let's say, in practice. So let's start with DANS. I'm pretty sure that not a lot of people in the room are familiar with that organization. I come from the Netherlands, and DANS is a data service provider. We exist since 2005, but we build on a number of much older data archives. So we have data that go back to the early 1960s in our archive. And we started off in the social sciences and humanities, so that is still a strong focus of ours, although we have expanded with our services to a lot of other disciplines as well. And this is reflected in our mission, which is very broad. It says that we need to promote and provide permanent access to digital research resources, so there is no mention of any specific domain there. We are an institute with a father and a mother. We belong to the Royal Academy of Arts and Sciences in the Netherlands, and we are also part of the Research Council in the Netherlands, NWO. So that is where I come from. And this is a slide that represents the fact that, and you all know that policymakers are more and more concerned and interested in the topic of open science. That is so on a global level. You can see here a report making open science a reality from OECD. You know that that is happening on the European level. We heard all about that this morning. The European Open Science Cloud is the focal point there. It happens in my country. You see a nice picture of my Minister of Education, Culture and Science there, who says that she fully supports the quest for open science. And you see a picture from your own country where you also, and we heard also about that, the National Strategy on Open Science. So policymakers are all in favor of open science. Part of that open science is the sharing of data. Open data is a big part of that. And why is that so important? Well, we heard this morning already about the importance of replication and validation of research outcomes that can only be done if data are shared. And this, of course, really adds to the integrity and the transparency of the scientific effort. So that is a very important motivator. Here you see a couple of headlines from papers and magazines talking about massive fraud cases that we were confronted with in my country a couple of years ago that really stirred not only the scientific world but the whole of the country, where it turned out that a professor in the social sciences had faked a lot of data and got a lot of exposure around his really interesting results that seemed to be based on nothing. So that gave a big push to open data and open science in my country. The question is whether that was for the right reasons, but that's another story. Because data sharing is also important with an eye on the reuse of data. We heard this morning already that the reuse of data makes research more efficient. It provides funders with a better return on their investment in research. But I think the biggest plus of it all is that you can stand on the shoulders of others, that it advances science. And of course, you can, when you share data, you can also do a lot of interesting interdisciplinary research. And I have two very simple examples. I myself am a maritime historian. I was a long time ago. So this example really appeals to me, which is an example that showed that making a study of the data that come out of 19th century logbooks from whaling ships helped climate scientists to understand climate change and see what happened. Because in those logbooks you had a lot of entries every day of ice conditions, weather conditions, etc., etc. Another nice example is this one, where it turned out that comparing climate data with medical data showed a correlation between air temperature and heart attacks. So you can see that by combining and sharing data, you can get some interesting results. So it seems a good thing for everyone, but what do researchers think? Here you see a question that was asked to a lot of researchers: how supportive would you be of a national mandate for open science? And you can see that the majority, a little bit more than half of them, strongly supported open data. So that's very good. But then we see hesitance in practice. And a recent international survey showed that at least 1/3 of the researchers is still not willing to share data. And of the 2/3 that do share data, again, 1/3 does stores the data on their own machine or in their own faculty. So if you do that, that doesn't make it very sustainable and also not very findable for others. So whether that is data sharing, I'm not sure. And why are researchers hesitant? Intellectual property rights, confidentiality issues, concerned about the misinterpretation or the misuse of their research, ethical concerns, concerns to be scooped. But very often I also hear from researchers that they say, well, it's my blood, sweat and tears. I spend so much effort on these data. They are mine. So we have a world to win there. Because how do we change that? And I think, how do we enable and how do we incentivize researchers to share data? I think we need a number of components. Cultural change is very important, and we heard about that this morning. Professional rewards for data sharing, data citation, seeing data as a really valuable output of research, of the scientific effort, just like publications, is very important. But also the way in which we train or raise our young researchers. If they are in a group, they have peers among them who do share, then we often see that young researchers are also willing to share. If the culture is different, it is very difficult to break that. So that is what we need. Of course, next to the carrots, we need the sticks. Funder policies can help, publisher requirements can help. And then we need infrastructure if researchers want to share data. They need infrastructure during research. Where do I store my data? How do I share the data during research? And we need trustworthy data repositories to store the data after the research is finished. Repositories that will be there for a long time, that can give guarantees, and that will offer a place also where reusers of the data can be sure that they can trust the data. And we need data experts to help the researchers in their research, writing data management plans, etc., etc. And finally, of course, we need research data management training for the researchers themselves. So all these ingredients are needed to enable and promote data sharing. So within the context of data management, the FAIR data principles are very important. They were invented, designed in 2014, and I had the privilege to be at that conference in Leiden, which was around the life sciences. By sheer coincidence, I was there because I replaced someone else, and that was the place where, for the first time, those four FAIR data principles were designed. The F, to make sure that data are easy to find, both by humans and machines, findable. The A for accessible. User license access conditions need to be in place around data, and open access, of course, if possible, but closed if you have sensitive data if needed. Interoperability, the data should be ready to be linked to other data in order to advance science. And the R for reusable, ready to be used, reused for future research. So quite generic data principles. They were published in an article in Nature, not long, well, long after that, 2 years it took. So that is quite long, but that's usually the case. And then there was set up a FAIR metrics group that zoomed into those 4 guidelines and tried to come up with metrics to make it more implementable. And nowadays we have seen that FAIR is going all over the place. We're not talking about FAIR data only anymore, but that was the starting point at that time, FAIR data and metadata, by the way. Now people are talking about the internet of FAIR data and services. All the services should be FAIR, training should be FAIR, tools should be FAIR, data should be FAIR. The whole world needs to be FAIR. What you also see is different implementations. For example, if you look at FAIR data, you can talk about the moment that the data is created. So a researcher should do that according to the FAIR principles. And you see all kinds of funders now also having that in their requirements for funding, for example, the European Commission. You can also assess existing data sets on their fairness. People are working on that to establish a profile for an existing data set. And there are also people now working on tools to transform existing data sets to a more fairer form. So you see all kinds of implementations popping up around this concept of FAIR. And also Europe, of course, has embraced the FAIR concept. We heard about that from René. We had the expert group that wrote a beautiful report, Turning FAIR into Reality. We have the Horizon 2020 program that has guidelines on FAIR data management. So FAIR has also entered Europe in that way. And we already heard about the project that just started the 1st of May. I'm not going to go into that, but that is a big project. 10 million euro will be spent by 22 partners to really find and provide practical solutions for the use of the FAIR data principles. The European Open Science Cloud needs to be fair. So what do we need for that? In terms of requirements for data, in terms of services and tools, and also in terms of training and awareness raising to make sure that there is that we foster a FAIR data culture and that good practices are taken up. So, to cut a long story short, everybody loves FAIR, and why shouldn't you? But then the question is, what does it really mean in practice, and how do you put those very generic practice guidelines and principles into practice? So I think there are a couple of things to say about the concept of FAIR. What I find quite difficult is that everyone now says we need FAIR data sets, and there are, you know, mandates that say data need to be fair. But I think that is, first of all, everyone has a different concept of what FAIR in practice means. But also, it is not doable. You can't say these data are fair and these data are not fair. It is a kind of continuum. So we have this ideal image of a data set that we want to strive for. But in many cases, the ideal situation will never be reached because you deal with sensitive data, because in the humanities you deal with very fuzzy data, etc., etc. So I see it more as a continuum where you try to get as far to the ideal situation as you can. So It's not a black and white thing. Next to that, fair data and open data are not the same. Partly they overlap, but you can have a 100% fair data set that is not open because, for example, it's a medical data set and it contains personal information. But for the rest, it's completely fair. The other way around is also possible, that you have a completely open data set, but it's not fair at all. So I have the feeling that these two concepts get mixed up here and there, but they are really different things. And of course, open doesn't mean always 100% free either. So what then is fair? In how I usually see it is that it is really good research data management. If you manage your data well, the outcome will probably be that you have a fairly fair data set. It is a buzzword, and it helps us. It helped a lot in the sense that we discuss this now, and it also makes us, go to this dot on the horizon, and we see a convergence there. But on the other hand, I also think that it is something that we have been talking about already for a very long time before we had this term fair. So it's a bit of old wine in new bottles sometimes. Here you see those 15 FAIR metrics or guiding principles that came out of that working group. And they are quite practical, but still I see a lot of people struggling with them. On the one hand, with the interpretation of them, on the other hand, with the way in which they could turn this into a reality. Very often that's quite difficult. What I do know, and this is a slide that I stole from Karel Luyben, who is the chair of the EOS Executive Board. Here you see his vision of open science, and you can see that fair data are very prominent in this picture. And I think that is for a reason, because fair data really is really an important, so good research data management and sharing of data is a very important element in open science next to open publication. And fair data means fair data through the whole data life cycle, of course. So I want to finish with one concrete example of how a community has tried to translate those 4 letters into a practical guide for researchers. And this example comes from a European project called Parthenos, and I don't know whether anyone is familiar with the project. It is a project in the humanities with a lot of organizations from different member states participating. So I'll fly through that. So they tried to make this easy guide, and they have tried to structure a number of guidelines around the 4 letters, 20 guidelines, and they have 2 groups of users for their guidelines. On the one hand, it's the data producers, so the researchers, who need as clear and as simple guidelines as possible, I think, to start good research data management. And secondly, it's aimed at the research infrastructures and the data archives, so the supporters of the infrastructure. And it's interesting to see that they start their work by stating that it is very important that there is an investment both in people and in infrastructure, that is needed. And that corresponds nicely with what I said before about enabling researchers to do good data management, cultural change, training, and infrastructure. You see here a little example also, they refer to it in this statement to a work that has been done within CESTA, and I know that also in Slovenia the CESTA community is quite active. So we have a training available which is focused really on research data management, which is focused at first instance on data experts, but is also very interesting for researchers to have a look at for further guidance for data management. So let's start with the F, the findable. Here you can see that they focus, when they talk about findable, on, of course, on easy access of the data, easy findability of the data, both for humans and computer systems. And they focus on the metadata in that respect, but also on the use of persistent identifiers. And they suggest that researchers make sure that they reference the persistent identifier that they use for the data in their research output, so that other people can find the data on which the assertions are based. There are some suggestions around the citation of research data, and also around the persistent identifiers for authors, also very important if you want to be findable for others. And of course about choosing the appropriate metadata schema. And here you see a little reference to a guide that is available online on persistent identifiers that helps researchers also get acquainted with the concept, and also explains which persistent identifier might be the best choice for you. So if you go to accessible, this is of course about well-defined access regulations, and making sure that the data, once you finish your research, end up in a place where they can be found, and also where they are accessible for others. And in that respect, it's very important that you find a trustworthy digital repository to put your data in. You need to state the accessibility, so you need to choose licenses, and of course, best thing is to choose a license that is as open as possible if the data allow that. And of course, there is always the possibility to put an embargo on your data if you still need to publish. But for example, at my archive, we try to incentivize researchers not to go in that area too quickly. So if you say that the researchers should look for a trustworthy digital repository, you ask something from researchers, because here you see the homepage of a registry of research data repositories called Re3Data. And you can see that there are almost 2,500 repositories and databases mentioned there. So where do you find the repository that is right for your data? That can be the proverbial needle in the haystack that you're looking for. Well, fortunately, over the last couple of years, there have become a number of certification standards available for repositories that they can acquire in order to prove to their audience that they are a trustworthy place, and that they take care of the long-term availability and accessibility also of the data. And the most successful one up till now is the Core Trust Seal, and here you see a snapshot of their homepage, and you can see that all in all we have almost 150 repositories around the world that have this, this stamp that provides you with the certainty that this is a good place to store your data for the long term. So the I and the R, the interoperability and the reuse, are the most difficult ones, the difficult aspects of FAIR. Interoperability means that your research data should be easily combined with other data sets to make interdisciplinary research, etc., possible, both for humans again and for computer systems. So what do you need for that? Need to do for that as a researcher? You need to make sure that you use open and well-defined vocabularies. You need to document your metadata models, etc., etc. So there are a number of tips here that you can follow in order to make your data as interoperable as possible. But of course, not all the data will in the end be interoperable and combinable by computer systems. I'm very aware of that. File formats are also very important, and typically you want to make the right choices before you start your research, because if you have to change everything at the end, that is very time-consuming and very boring to do. So it's always good to think in advance about where you're going to store your data and have a look at their file formats. Very often repositories have preferred formats for which they guarantee a long-term preservation period. So that is also a very useful thing to do. Finally, the reusable bit, talking about the readiness of your data for future research. And there it's very important that you have ample documentation of your methodology, of your data, etc., to make them interpretable for other reusers. That has to do with naming conventions, again, file formats, also version control methods, etc., and the licensing for reuse. So this was just a little example to show you how complicated the implementation of FAIR can be in real practice. But there are coming more and more tools and services available online that can help you with that. Here again, you see everyone loves data, wants to share data. So the intent is there, but how to make it a reality is quite some steps away, I think, and we need a lot for that. If you are interested and you care about data, one of the things you can do is join the Research Data Alliance, which is an international organization that you can become a member of with no cost, just registering on the website. And we have 8,000 people already joining that initiative around the globe. And there is now a regional RDA Slovenia node, and that is really, really good. And this node is quite active, and I can tell you that they are now working on activities around citation, funders and open access, and that they will also organize 2 workshops for researchers from all disciplines on open access. And I stress all disciplines because I understand that this initiative started off in the social sciences and humanities, but wants to expand now to other disciplines within Slovenia. So please, join that organization, and we have someone in the room here who represents the RDA node, so maybe you can stand up. Anyone who wants to know anything about it can come to you. Good. So, and with that, I would like, I know it's still 195 days away, but the actual birthday, but nevertheless, I want to congratulate you with that 100 years. And with that, I would like to finish. Thank you very much.
Thank you, Dr. Dillo. It's switched off. Yeah. So, is there any question? Any burning issue? Do you have any question? So everything is clear. You all have FAIR data.
What to know.
Yeah.
FAIR data in Slovenia.
Yeah, and data management. And maybe I have a question. Yeah. How do you foresee that the data management should be done, for example, on organizational level? You know, by every researcher, by himself or herself following the guidelines, or I'm implying a little bit on data stewards.
Yeah. Well, then maybe the best example I can give is from my own country. What we are trying to do in the Netherlands is build on a division of tasks and labor based on our the different expertise that is available in different institutions. So we talk about a back office, front office model, where we say that the universities are the front offices and the research institutions. They are closest to the researchers. So the university, and very often you see the university library taking a responsibility there, should raise awareness amongst their own researchers and provide support and training in the area of research data management, should support researchers that want to write a data management plan. But in the back, we have in the Netherlands a couple of organizations that have a national remit. We are one of them, so we have specific expertise in the area of long-term preservation and curation and research data management. So the people, the data expert at the front offices are trained by us, and they can also use our expertise to serve their local audiences. So we try to organize it this way, because for us it's impossible to reach out to all the researchers in our country, so we use this phased model of a front office and a back office.
Thank you. So now, is there any more question, opinion? Yep.
Question. Yeah. A very brief question. You mentioned, but it was mentioned before as well, that one of the reservation for sharing your data is that you work hard for it and you want to use it and you want to publish as much as possible. And one possible way out of that is that the researchers get some kind of a reward or some kind of a recognition. Is there any good practice or good practice example? What kind of rewards and what kind of recognition?
I think we're far from that at the moment. We talk about it, but it's not in place. For example, within my own institution, we try to do that in really simple ways, you know, by having, for example, a national data prize, where we put someone each year in the spotlight in the Netherlands who curated a beautiful data set that is of use for a lot of people. But what you really would want is that you get academic credit for also, just like you get for a publication, for curating a data set and documenting it in such a way that it can be reused by a wider audience than just the peers that are aware of your specific field of expertise. That would be the ideal situation.
Yeah. So, can I ask? So Slovenia is actually Irina Vipavc-Brvar talking from Slovenian Social Science Data Archive. So in Slovenia we have this possibility. I think it's one of the one case from SESDA archives that actually data that are archived in Social Science Data Archive get academic credits in our academic systems. So that's one of the things. Yeah.
Then you are very advanced there. We are only talking about it in NWO, not doing anything yet.
Is it enough? I mean, enough points
It's not enough
for researchers.
Maybe we have, how to say, also a complementary idea. You know, we want to establish a faculty archive. I'm coming from Faculty of Medicine. And actually the reward for the researchers would be that they get storage and archive for free. Only obligation they have is to put in the metadata. Yeah. Okay, and we'll see how this will progress. Yeah. Okay, thank you. So any more opinion, or we still have 1 minute? Okay. Now we are well in time, so thank you again, Dr. Dillo. Yeah.